Hello world, my name is Marcus Jones and welcome to a special episode of a PowerPoint about. Today's PowerPoint is about the ISA4220 vulnerability assessment. Over the past 5 months, the ISA4220 class has maintained two servers, one for Windows and the other for Linux. This report is a culmination of that research, and I will delve into the different research methods used and the results of those efforts. This report provides an analysis and evaluation of the final state of Jeremiah Smith's Windows and Linux operating systems for ISA 4220. Methods of analysis include a checklist of required services for each operating system, XenMap and vulnerability scans from each server along with screenshot images of the results of the scan, screenshot images of Linux firewall configurations, screenshot images of AppArmor rules and profiles, and lastly, greenbone scans of each server IP address to provide vulnerability information. The process began by using the required services checklist in conjunction with the XenMap scan to ensure that all services are installed and properly filtered. Upon this scan, research discovered that two services were not properly configured. On the Linux server, port 5432 for PostgreSQL is showing as filtered and it should be open. On the Windows server, Simple Mail Transfer Protocol Secure, or SMTPS, on port 587 is a required service and it is not active. These two issues should be corrected to ensure that all required services are configured correctly. Lastly, a greenbone scan was done to find vulnerabilities in the two servers, and more issues were found. There were a total of 5 alerts that flagged during the scan, and 4 of them were medium severity alerts on the Linux server regarding ports 993 and 995, flagging for weak TLS/SSL ciphers, as well as vulnerable Diffie-Hellman key exchange. These ciphers must be removed in order to secure the service. There was only one alert for the Windows server. The alert was for a medium severity alert on port 445 for TLS/SSL reporting vulnerable cipher suites. This issue can be mitigated by strengthening the cipher key for this port and disabling the weak cipher suites. Overall, the findings concluded that the servers were well secured and there were only 2 services incorrectly configured and only few medium level alerts that can easily be corrected. The Linux server reported 4 different vulnerability alerts and they all involved TLS and SSL authentication. There is a medium severity alert on the Linux server for Post Office Protocol 3 on port 995, having weak TLS and SSL cipher suites. These cipher suites are instructions of how to properly secure a connection through TLS or SSL. There are algorithms that are used to determine how a web server will securely transfer information from the client over the web. In this instance, the bit size of the cipher is not sufficient to properly secure the service and is considered to be weak due to its vulnerabilities and must be disabled. Port 993 for Simple Mail Transfer Protocol showed the same exact issue and will have the same remedy as port 995. To solve this issue, users should implement stronger TLS and SSL cipher suite requirements on the server. The current cipher suites being used are 128 bits, which falls short of the required 256 bits to be secured. In order to secure the server, the user must disable the weak cipher. To disable this weak cipher, the user should first access the Apache configuration file for TLS and SSL. In this file, the user will replace the current weak cipher with a command that will remove all other protocols and ensure that the more secure TLS 1.2 cipher suite is the only one being used. Another medium severity alert that flagged on the Linux server was again both for ports 993 and ports 995 for TLS and SSL errors. This time, it was for the Diffie-Hellman key exchange having insufficient group strength. Diffie-Hellman key exchange is used to transfer information securely through TLS and SSL. It allows 2 unknown parties to establish a shared private key so that they can communicate securely over a connection. The issue on the servers is that the strength of the Diffie-Hellman group being used is 1024 bits and is considered insufficient and vulnerable to attack. In order to fix this issue, the user must upgrade their Diffie-Hellman group strength to 2048 bits in order to properly secure the service. In order to remedy this issue, users will have to deploy a stronger Diffie-Hellman group that has 2048 bits or more in order to secure the service. Diffie-Hellman groups are used to determine the strength of encryption algorithm used during the key exchange process. The higher the group number, the more secure that it is. Using OpenSSL, users will enter a command to generate a 2048-bit group, which is an upgrade over the default 1024 bits. Users will also access the TLS SSL file in Apache to configure the service to reject insecure protocols and use the more secure TLS 1.2 during Diffie-Hellman key exchange. A database issue was found during the ZenMap scan of the Linux server. Port 5432 for PostgreSQL was showing as filtered when the port should be open. Having this port filtered will prevent PostgreSQL service from working properly because access will be blocked by the firewall rules that have been set. PostgreSQL is used as a data warehouse to store organization files, and when filtered, the user will not be able to access the service and therefore not able to access the data stored within the service. IP tables rules should be updated to open the port for the service and ensure that the user has access to the database. In order to open the PostgreSQL port, the user must change the IP tables rules to allow traffic into port 5432. To do this, a user must first remove the current filtered setting by first entering the command sudo space IP tables space L line numbers. This will display the line numbers for each IP tables rule so the user can remove the correct line. Once the correct line number is identified, the user can delete the rule that is filtering the service. The command to delete the line will be sudo space IP tables -d input and the blank space of the corresponding line number that needs to be deleted. Once the filter rule is deleted, the user can leave the service as is and it will be open for access, or if the user would like, they can add a new rule to accept access to the server by using the command to allow incoming traffic to the port. There was a medium severity alert on the Windows server for Hypertext Transfer Protocol Secure, or HTTPS, on port 445 having weak TLS and SSL cipher suites. These cipher suites are instructions of how to properly secure a connection through TLS or SSL. The suites are algorithms that determine how a web server will securely transfer information from the client. Weak cipher suites mean that the services are using encryption and decryption algorithms that contain keys that are proven to be vulnerable to attack based on the bits involved in authentication. The error that appeared in the Greenbone scan for this server stated that the cipher suite was using 3DES, which is a 64-bit cipher vulnerable to the Suite 32 attack that can allow a hacker to see communications in plain text. In order to secure the HTTPS service, the user should disable this weak cipher. To disable the 3DES cipher, the user should navigate to the cipher suites list by pressing the Windows key and R together to open the group policy editor. Next, the user should select Computer Administrative Templates, then select Network. After that, they will click on SSL Configuration Settings, and then they will select SSL Cipher Suite Order, and inside of this menu, they will deselect the 3DES Cipher Suite. This will remove the weak cipher suite and help secure the service. The final issue that was found was with the SMTPS service on the Windows server. SMTP is not showing as active. SMTPS is used to secure SMTP service by adding TSL SSL layer of authentication to ensure that the connection is secure. Without SMTPS being active, any traffic being sent on the SMTP server could possibly be intercepted. Users should ensure that SMTPS is equipped and running so that communication on the SMTP server can be protected. To fix the issue of SMTPS not running on the server, the user must configure the service themselves. To use SMTPS, a user must first install SMTP. To do this, a user will open Server Manager from the Start menu, select Add Roles and Features, and select SMTP to be installed from the list. Once SMTP is installed, users will use Internet Information Services Manager, or IIS, to manage the settings of the SMTP server regarding who can access the server and the type of authentication on the server. In order to enable TLS encryption security, users will have to navigate through IIS by selecting Properties, and then next the user will select Delivery. Next they will select Outbound Security. They will check the box that states TLS encryption, click OK, and then click Apply. This will apply TLS encryption on outgoing SMTP activity and help secure the service by involving encryption. Overall, Mr. Smith did a great job with his servers. There are only 2 required services that were not properly installed, and those issues can easily be fixed. More importantly, the security of the server was adequate to the requirements of the checklist, and no insecure ports were left open. There were a few vulnerabilities on the secured services, but they are easily fixable by following the steps provided. Overall, the server is secure and working properly. Thank you for watching my PowerPoint. These are my references. And for one last time, goodbye world. Thank you.